Okay, so hey viewer, today we will be solving the problem for printing the subsequences whose sum is somehow equal to k. So here you guys will be given with something like an array, something like as 1, 2 and let's say 4, and k as something like as 4. No, it is something like as 1, 2, 2 and k as something like as 4, and you will have to print the number of subsequences or the subsequences whose sum is somehow equal to k, which is 4. Okay. So if you haven't watched the previous video where I was finding out the number of subsequences for a given array, then please go and watch and then only come to this particular one. So what I have to do, I have to find the subsequences whose sum is somehow equal to k. So what I'll be doing here, I'll be trying to find all the subsequences of the given array, okay? And the subsequences whose sum is somehow equal to this particular value k is found, I'm going to print those subsequences. Yes. So what I have to do, I have to find the subsequences for this particular given array. So how to find the subsequences? Yes, we know the basic take and non-take approach for that in order to find the subsequence for a given array, and we will try to find the subsequences, and we have to carry a sum for every given subsequence, and for whatever the subsequence that I have found, if the sum is somehow equal to this particular k, I'll going to print that one. Okay. So what I have to do, I have to carry a sum variable with myself. Okay, so we can make a dry run for this particular one. Suppose if I'm starting from the index 0, 1 and 2. Okay, so if I'm starting from the index 0 and the sum that I have, because I haven't taken any element till now, is something like a 0. So how the caller function is going to look like? Something like as the index which is initially 0 and the sum which is also initially 0. Makes sense? This is a caller function. Now just think about this particular guy. I am at the 0th index. Okay, so I actually have two options. I can either take the first element, or I cannot take the first element. So what I'll be doing, I'll be taking the very first element and then I'll be moving for the next particular index. So my sum will become something like as 1, because the value at the first index will be 1. Then how recursion works, like left left left, ultimate leftmost, then right. Makes sense? So I have to go for leftmost. Then for this particular function which is at the index 1, I'm at index 1, so I have actually two options whether I'll be taking or not taking. So I'll be taking this particular value and I'll be moving to 2, then it will become something like 2 plus 1 will be 3, then I'll be moving for something like as 3, then it will become 3 plus 2 will become 5. Now I'm at index n equal to 3. What is n? Size of array 3. So when you are at the index something like as equal to n, what will you be doing? You will be asking for, hey sum, are you somehow equal to whatever the sum required, which is k? I'll be like, no, I'm not. 5 is not equal to 4 basically. So what I'll be doing, I'll not be printing, I'll simply say that return. Then I'll be going for this particular guy, 3 with 3. Hey, you are at the index 3. Are you equal to the sum? Like, no, I'm not. Again, go back. Then remove this particular added guy. Okay, then you will be coming for this particular 2 with the same one value. You will not be taking this one guy element. Now for 2, what you can do here, you are at the index 2. You can take the value of 2. So it will become something like as 2, and 1 plus 2 will be something like as 3. Then for, no, you have to move for the third index. Sorry, third index. Now you are at third index and the sum is something like as 3. You will be like, no, this is not a sum that I have to form. Again go back, remove this particular 3, then come for a 3 for 1. Like, no, this is not the sum that I am trying to form. I'll again go back, go back, go back. Makes sense? So by not taking this particular first element, I don't got any subsequence. Makes sense? So now what I have to do, I have to go and take this particular 0, sorry, and I have to go and not take this 0, then I'll be directly going for this particular 1. So I'm coming at for the index 1 with the same sum which is 0. Now what I have to do, I have to go for this particular 1 in order to take, I'm going for the left now, so I have to take this particular 1 element. So what is it? It is 2, and then I'll be moving for the second index. Now from second index I can again move for something like as third index. My sum will become 4 this time. Okay, so now I'm at the index 3 and my sum becomes 4. So I'll be like, hey, I got the sum, I got the sum. So what I'll be doing, I'll be simply printing the data structure which I'm carrying with myself. What is the data structure? It is simply like a 2 comma 2. I hope this makes sense to MI. And then I'll be returning back from here, and then I'll be at here, I'll be removing this particular value and I'll be going for here f of 3 for 2. No, it is not the sum that I'm trying to form. I'll be go back. Now from here I'm taking 1. Now I don't have to take the 1, I'll have to move for second with the same particular sum. Now I'm at the index second, I'll be taking the second index, I'll be moving for third, and my sum will become something like as 2. Okay, 2. So my sum becomes 2, and okay, now here I didn't got the sum, so I'll be going back. Now I'll be again coming for 3 with 0 value, didn't got the sum, go back, go back, go back. So I got only one subsequence whose sum is somehow equal to k, which is 4. Makes sense? 2 plus 2 is a 4, and that's what. So I hope this makes sense to your mind. Okay, so what I'm actually doing, I'm going for take, I'm going for not take. Okay, and then I'll be finding out the subsequence whose sum is somehow equal to k. So how the pseudocode for this particular program will look like, let me tell you. Okay, so how's my caller function? My caller function will be like something like as if of I'm starting with the 0 index and I have sum as something like as 0 initially. Makes sense? So this will be my caller function. Okay, now what could be a base case? So let me write here, it should be something like as a index here, and then this will be a sum, and then I have to carry out data structure which will be storing that subsequences whose sum is somehow equal to the k. So in any possible case, if I am reaching to the last index, which is index equal to n, I'll be checking one more condition. Hey sum, are you somehow equal to k? If you are, then I'll going to print that data structure. I'll be printing that data structure. Makes sense? And then I'll be simply like return from here. Okay, because the task is done now. If that's not the case, that means the index in between something like a 0 or 2 for this particular example. So what I'll be doing here, I'll be like, hey data structure, can you please add this particular array of index into u? Like, okay, I'll be adding, and then I'll be calling the function for the next particular index. But this time, just because I have added this particular array of into a data structure, I'll have to add it into a sum. So sum will become sum plus array of index, and this data structure is what I have to pass. I hope this makes sense. Now this guys go and comes back, a leftmost call has been done. Now what I'll be removing? I'll be removing this particular array of index from the data structure, because now I don't have to take into me. So like I'll be like remove this particular array of index from to u, and then I'll be again calling this particular function for the next index. Now my sum will stays as sum because I have removed that particular array of index, and this data structure as it is, and that's how this will going to work. So yeah, this is a pseudocode. I'll be sharing the exact code in C++ into a description section. So if you like this, please hit like. Thank you.